In this video, I will talk about one very important topic, which is computational complexity in artificial neural network. These are the formulas that I will explain over here. These are the formulas. There are two formulas written over here. And the artificial neural network, the simple neural network has been displayed over here. So let me just start from a motivation. Suppose that we have a topic, we have a course that is numerical analysis, for example. In numerical analysis, you probably know that we have to develop or study different algorithms, and these algorithms are good or bad. It depends on many, it depends on different criterias. But one of the criteria is to look at the look at the complexity of that algorithm, and that complexity has been calculated from the how expensive this algorithm is, how expensive this algorithm is. And what does expensive means? It means that you need to calculate, for example, flops. Flops mean floating point operations, floating point operations. How many flops are required for any algorithm? This is one of the criteria in numerical analysis. Floating point operation tells us that how many multiplications and additions, divisions are required for any algorithm. Since this will affect on the computational cost of that particular algorithm, right? So similar to this motivation in numerical analysis, we also have a computational cost of the artificial neural network. So we will talk about that now. Okay. So first of all, you need to understand that in this artificial neural network, for example, you can see over here, maybe I just copy that and put it in the other page so that we can explain it in detail. Suppose we have this simple neural network, and in this neural network, there are two inputs, and there is one hidden layer with three neurons, and there is only one output over here. I did not actually write a connection from input x2 to the hidden layers neurons. Okay. So you know that when we um, reach over here, then you need to multiply x1 with the weights, and also you need to add the bystrum as well. That is just an addition. And after that, you have to apply the activation function to get the answer for first neuron. So you do the same for the second neuron, for example. You calculate all the hidden layers, all the weights first. You find the connection from x1 to the second neuron of hidden layer, then x2 to the second neuron of the hidden layer, and we multiply that together. Okay, so there is some kind of multiplication involved in that, right? So It means that we have to incorporate how many hidden layers are there, how many layers are there, and how many activation functions calculations are there. So uh, uh, the first formula for the multiplication is, suppose we have wi that tells us that how many weight functions have a connections. For example, for x1 to the this neuron, and we also have, for example, this neuron has two connections, W111 and W2, no, W1 and 21. Okay, so it has two connections. Similarly, we have W1, which is layer number 1, connection from input to hidden layer 1. And then we have, for example, we calculate the weights. So we have, for example, 1, 2, then we have 1, 2, 2. Similarly, when we have a connection from X1 to third neuron, then we have, for example, W1, 1, 3 and W1, 2, 3. So how many weights are there for the connection from input to the hidden layer 1? We have 6 weights. We have 6 weights over here. So we describe this in the formula as Wi. How many weights are there from input to the hidden layer? Then what we have, for example, number of neurons over here. How many neurons are there in the hidden layer? There are 3 neurons. So we multiply this with 3. So to find out the cost, we need to multiply the weight, all the weights with the SI. We are putting I over here since there can be many hidden layers, or we should say that we should have many layers in the artificial neural network. Then to calculate the multiplication, for example, we add one constant Cm over here. So that will become our formula. We have W, then we have number of neurons, and then we have, for example, the cost of multiplication. It depends on the software or your computer and architecture of your computer. So let me just write it in the in neat form. We have, for example, Wi, then we have Si, and we have Cm. Okay, since there can be many layers, so we need to add, we need to put the summation over here from I is equal to 1 to number of layers h. That is the formula of cost of all the multiplication m. Okay, similarly, we write the formula for the activation function. This is the cost. You know that when we reach over here, after all the calculation for from this z to 1 1, we need to apply the activation function, which look like this x w plus Bystrom. So there are 3 activation function. One is one activation function, but it applies to the neurons, all the neurons. One neuron activation function you apply on the formula. Then we have second neuron, you apply the activation function, so on and so forth. So For the activation function, we also have the same formula. We just need to modify the notation. This will show us that we have activation cost of activation function, and then we have, for example, the cost of C of A, which is just a constant. So we can calculate the activation function from this formula. The total cost from moving towards the forward propagation from the input to the output, then output to the input. It requires two, uh, two, two-way. Okay, so we should multiply. First, we need to add these two things. The total cost will be equal to cost of multiplication plus cost of activation function. That will be equal to I is equal to 1 to H W I S I C M plus I 1 to H W I S S I, and we have C A. We just add these two terms. So we have, for example, remember that we are only talking about moving from input to the output over here. The total cost will be two times of that. I1 to H WI SI, then we have CM plus CA. The total cost will be equal to the two times of that. And if you are talking about the cost of artificial neural network, it means that there is some sample and we multiply with the sample. For example, if you have 1,000 samples, training samples, your sample can be, for example, 200,000, and from that 200,000 you pick, you collect for training only, for example, 100,000 or 100,000, some other subset of that total sample. Okay, so if you move from input to the output and come back, we talked about that thing. But if you want to move forward and backward again and again, maybe n times, then we have, for example, the cost of artificial neural network will be, for the one shows that we have only from one, left to right and right to left. But if we have, for example, n, if we have n cost for n artificial neural network, we simply copy that, we just copy and paste over here. So then the formula will be n times 2n x mod is a sample, x is a sample. So the cost of moving from left to right n times, which is epochs, that will be equal to order of n x mod h w s and cm plus ca. That's how we write the cost, by writing the order of that order of the cost, order of the function, and so on. Okay, so suppose, let me just talk about one particular example. Suppose we have 32 layers, 32 layers, and then we have 32 in neurons in each layer, and the data is, for example, the sample is 10 raised to power 5. And how many iterations we have? For example, 10 raised to power 4 iterations are required to find out the optimized weights and the bystrum. So for that, we have cost 10 raised to power 4 of artificial neural network. We have, for example, we put 2 first, 2 times, and how many n's are there? 10 raised to power 4 iterations. Then we have, for example, what is the sample size? The sample is 10 raised to power 5. It is the training data. Then we have, for example, I is equal to 1 to how many layers are there? There are 32 layers. 30 the layers calculated from excluding the input. And what we have, how many weights are there? We have weights, for example, 10 raised to power 3, and we have, for example, Cm plus Ca. We keep this as a constant since it depends on the software of it depends on the software or your computer, laptop, whatever you have, PC. Then when we get the idea, so it is around order of 10 raised to power 4, 5, 9, and 12, order of 12 approximately. It is order of 12 cm plus ca. So solving your problem with this computational information, we need 10 raised to power 12. uh, that will be the cost of artificial neural network by solving this. But it varies. Suppose we have many neurons, you have a much bigger sample, then you probably need more cost. So this was a simple idea. You may probably search it yourself further, how the computational cost affect the artificial neural network. Thank you for watching.